Welcome to the podcast that is always up to speed with Formula One. Joining you as always from the beautiful city of British Columbia is myself, Mark Hamilton, Mr. Mark Daly, the legendary co-host of this show, having operated it now for 5 years. And today we have an incredibly special guest, somebody that our listeners have been asking us to bring on the show, not for weeks, but for months. We're incredibly happy that we're able to bring on today Bryson Sullivan, aerospace engineering graduate student and Formula One and automotive enthusiast extraordinaire, and also, quite frankly, and I don't think I'm exaggerating when I say this, a bit of a Formula One Twitter goat, to be totally honest. Mark, Bryson, how are you both doing? Mark, how's your week been?
It's been busy. I'm glad that the long weekend is finally here, pretty much. Just Friday to go. So I'm ready for it. Bring it on.
Absolutely.
I am also very happy to be here. I'm looking forward to some actual racing this weekend.
Yes.
But I'm also looking forward to having a great discussion with you guys today.
Fantastic. So Bryson, I want to kick this one off. I think, to be totally honest, most of our listeners are probably pretty familiar with you. They've seen your work, your posts on Twitter. The content that you produce is exceptional. And I think it's pretty clear for anybody that follows that from an engineering and an aerodynamics perspective, you have this absolutely absurd understanding of those properties and the philosophies behind them, and also a really fantastic way of articulating and making those concepts accessible to folks. So maybe before we get into some of the topics at hand, would you mind giving everybody kind of an introduction on your background, your specialty? And if you want, I'd really love to understand how you got drawn into the world of Formula One and what it was about Formula One that you found so compelling.
Wow, that was an incredible introduction. I feel honored. What I would say is that I'm an engineer by trade and Formula One enthusiast not by trade, right? But I'm a graduate student in aerospace engineering. I study hypersonics. I have previous experience in, I guess you would call aerothermoelasticity. But right now I work on scramjets. I can't tell you exactly what I do with scramjets, but it's cool, right? In terms of Formula One, there's something about this sport that speaks to me, and I don't know exactly how or why it started. But even if I'm not the smartest person in the room discussing something, I usually have an ability to kind of convey ideas in a way that's a little bit more accessible to people. So I am by no means a Craig Scarborough or Sam Collins by any stretch, but I'm trying to help in the work that they do. So if I can help at all, that's what I will do. In terms of how I got into Formula One, like most great things in life, it was kind of an accident, if I'm being honest. I was doing an engineering internship in South Bend, Indiana, and there were some other interns working with me that happened to be from Mexico. They were extremely enthusiastic about going to this Formula One race, and I said, "Why would I ever do that? Why would I spend my time going to watch cars go around?" And they said, "No, come on, it'll be a lot of fun. We'll have fun together." I said, "Fine. I'm not doing anything this Sunday anyway." This was in 2005, mind you. Okay. So my first exposure to Formula One and motorsports writ large was actually the 2005 Indianapolis Grand Prix.
Okay? Oh, wow.
Wow. Now, I did not know that.
I know, I saved it because it's more fun to reveal on air. What I think you might not get from that is that experience was not negative for me at all, because what I was actually exposed to was what you don't get in TV. You don't actually understand the speeds involved, the scale involved, the drivers dancing on the limit of adhesion at 200 miles an hour or whatever it is. There are some intangibles there that I saw for the first time unfiltered, and it spoke to me in a way that I really appreciated. So even though there were only 6 cars there and Thiago Montero was third, I enjoyed the heck out of it. And I've been involved in some form or another in Formula One for quite a long time, but haven't really utilized Twitter as a platform to communicate that until relatively recently.
You know, it's fascinating, Bryson, that you should say that, because I don't want to say that I'm a Formula One fan by default, but I picked it up from my dad, who was a big Formula One fan. It's sort of something that's always been there. And even as a young kid watching in the day, or back in the day, where we would have like 1 hour, 30-minute highlight shows on CBC, you wouldn't get a full race. It was just something I always found very compelling. And I wasn't until my early 20s that I actually got to go to my first Grand Prix, and that was at the 2001 European Grand Prix at the Nürburgring, and I went with a bunch of friends, and we were sitting at the hairpin at the bottom of the track. And very much like you say, I don't think that you don't really know what to expect until you see it for the first time in real life. Because if you go to the Nürburgring, that is actually an ideal place to sit, because you're sitting at the bottom of the hill at the hairpin, and you see the cars come from the starts. Well, you don't see the start, but you see them come through the first series of corners, and they come down down the hill through this series of very sharp or short, snappy corners down into the hairpin. So you see the cars, the cornering ability. You see them put the brakes on going into the hairpin, and then you see them accelerate as they come out their hairpin and up the hill. And then there's a very fast left-hander. And I remember sitting there because we were there for the Saturday and the Sunday, and then just watching them in practice and in qualifying. I was just absolutely mesmerized by the performance of the cars. It was just like, it's amazing on TV, but in real life, it is really something else.
Yeah, I would just piggyback on that. I mean, it really became a visceral experience for me the first time that I like smelled a lockup. Right, like you see lockups happening all the time in a race, but when you actually can smell the rubber, it changes something about
Yep.
the experience. And the atmosphere of a Grand Prix is unrivaled. We're so used to the Formula One fans being spread out in this kind of diaspora, right? We're not ordinarily concentrated into one place. And when you actually go to a Grand Prix, you're surrounded by people who think like you and feel like you, are equally passionate, if not more passionate, than you are. And it's a really special environment. So it's really the perfect blend of driver athleticism, technological prowess, really, and scientific understanding, engineering understanding. Fundamentally, to be fast, you have to know something about physics. And that's a really, really cool thing.
Formula One is such an interesting sport on so many levels. And I think that sometimes maybe I guess this is a sort of a subjective opinion depending who you speak to, where it is we tend to focus on a specific driver and a specific car, and we sometimes maybe overlook the ultimate team game that it is really. Because I mean, we all look when you're watching a football game or a baseball game or a hockey game, basketball, whatever, because you see you've got 5 versus 5 or 11 versus 11, whatever the sport is, and then you've got the coaches on the side. And we tend to overlook the fact that there is X number of people on the pits, in the garage, back in the factory, all these, in some cases, hundreds and hundreds of people that are putting all this energy, all this work, all this focus into building and designing these cars. And when you think about it, the driver is just one other piece in the equation, but that person obviously is a very key component of it, because of all these different, widgets and different bits of technology and the tires that go onto it. That person that is in there to drive the car is just, is equally crucial as anything else in it.
Yeah, there's nothing else in the world that's like Formula One. I don't know how else to describe it. It is a completely unique circus. I'll put that in a loving quotes, circus. But it's an extraordinary atmosphere, to be sure.
Yeah, and that's a great word. Circus is so accurate. I think the way to describe Formula One, especially like we've seen at different times this year after Silverstone, for example. Just the I'm trying to find the right word to describe all the let's just say the noise that came out of Red Bull, and all the distraction that it really became with the incident between Lewis and Max Verstappen. I mean, circus, I think, is a very kind way to put it, especially in that situation. But it's very funny too, because when you think about it, Formula One, like, I've always had a fascination in fast things, as cars, airplanes. Much like yourself, like I've had a lifelong fascination with fighter jets, high performance aircraft of any kind, even though that's just a pure interest. And I was very interested to see a thread that you were commenting on a couple of, I guess it was a couple of weeks ago now. And I think it was a picture that somebody had posted to Twitter of an F4 Phantom. And it was interesting, just the way that you'd explained it. You could just tell by the different gradients, just which you could see in the photograph, just regarding the amounts, I guess, from the exhaust, also the airflow over the wingtips, and the different air surfaces of the aircraft. Could you maybe explain that a little bit more? I'm very interested in that, because where I wanted to go with that is, of course, when you see a picture's worth 1,000 words. And I was always wondering, after that little exchange I saw you commenting on, are you able to pull similar amounts of information out of Formula One, specifically during a television broadcast, which might be kind of difficult, but I'll let you take that one away.
Uh, if you know what to look for, you can. So the first thing I would say is anytime that you see condensation or a cloud trail following an aircraft or a F1 car or anything, that's always an indication of low temperature and low pressure. No matter what's causing it, whether it's the aerodynamic lift of a wing or it's the core of a vortex, any of those things, that's always going to be there. It's always a result of low pressure and temperature. One of the other things, though, is that whenever you look at these flow visualization situations, as you mentioned with the F4, I believe it was, the density also changes in interesting ways, and light behaves differently in a dense fluid than it does in a rarefied fluid. So if you have a gradient where it's very, very low density in the core of a vortex, for example, and higher density outside, the light actually bends differently through that area, and you can actually identify it purely by visual inspection. In the scientific context, these would either be shadow graph or Schlieren imaging techniques, but even just a regular camera can pick up quite a lot of it if you know what to look for and where to look for it. And if F1 specifically, if it happens to be raining, that's a day to stay up and to really look at the pictures, because not only will you get the smear pattern around the surface of the vehicle, which can tell you where there's flow separation, where the flow is attached, how well things are working, but also you can physically see some of the vortices better when it's wet. And there was one slight example of that was a little bit different in Bahrain in preseason testing. We didn't get water visualization, we got sand visualization. And even though that's not quite the same thing because the sand particles don't track the fluid perfectly, you could see some incredible aero working there. So one thing I will say at the top of our discussion is there is no enterprise in the world that I'm aware of where aerodynamic development occurs as rapidly, as vigorously, and as in a detailed way as Formula One.
Incredible.
They are rapid prototyping parts at an incredible pace, much faster than anything else, number one. And number two, the actual type of aerodynamics is incredibly specialized. We are talking about extremely heavily aerodynamically loaded surfaces operating in close conjunction with a ground plane. Those two things together produce something that's utterly unlike anything else.
Fascinating. Mark, I know we've got to cut to a break, and I think we have got a really great, exciting segment, and we're really going to dig into aerodynamics, and we've kind of titled the next section Aerodynamics 101, and certainly there's nobody better in the world to take us through those concepts and philosophies than Bryson. But before we go, I'm really curious, because as much as I knew about you, I wasn't aware that you became a fan of Formula One as far back as 2005. So you joined pre-Lewis Hamilton, and at the very tail end of classic vintage Michael Schumacher before the Washington Wizards years with the Mercedes team. Given that early on, who were the teams, who were the drivers that you found enthralling, that you were attracted to? And even today, is there a specific team for functional purposes, for performance purposes? Early on, who were you attracted to? And today, which are the teams that you feel most compelled to follow and support?
Early on, it was Kimi in McLaren. The MP420 was the first car I genuinely fell in love with, right? That car looked unlike anything I'd ever seen before. It sounded unlike anything I'd ever heard before. It was love at first sight, even though no one at McLaren knew that I loved it so much. But it was the first F1 car I had a poster of. So I was definitely Team McLaren early on. I'm not part of the Ham-Fosi proper, right? But I am a Lewis Hamilton fan, and I'm a huge fan of the work that he and Mercedes have done together, not only in their success on track, but also in the Hamilton Commission, Accelerate 25, so many things that they did not have to do, but the fact that they did do it is an incredible gesture, is an incredible effort, gesture of goodwill to so many people. So for me, I am a big fan of Mercedes. It's definitely my number one team, but I also appreciate Red Bull. I have Red Bull paraphernalia as well. I could have worn it just to prove my neutrality. But Red Bull is a unique person, a unique group in the Formula One paddock, because they're not constructors in sense of manufacturers with an automotive brand to hold on to. They're a disruptive operation, and that puts them in a very unique part of the business space that maybe allows them to do things that other teams can't quite do. So I understand and appreciate that, although I think they made some unfortunate decisions after Silverstone, which we can get to after the break.
Yeah, to say the least. To say the least. Okay, guys. Well, that's a great place. We'll just park it here for a quick moment while we take a very short break to hear a word from our sponsors. So, guys, don't go away. We'll be back in just a moment. All right. Well, welcome back to the show. You're listening to the podcast that is always up to speed with Formula One with Misters Mark Daly and Hamilton and special guest co-host Mr. Bryson Sullivan. So, guys, we've had a little chance to get to know each other here, and yeah, I'm still trying to put my brain back inside my head here that you managed to sit through that 2005 US Grand Prix as your very first live exposure and still managed to hang on as a fan. But it's it is so funny because we reference that race occasionally on this show. I mean, some of the listeners might actually have a running tally, but you're the first person I think I've ever spoken to in person that was actually there, which is awesome. And I can still sort of picture it. But you were saying that your favorite car that you really sort of latched onto was the MP420, the McLaren, the one that I go back way back in my childhood that I don't want to say it haunts my memory, but it's one that's sort of etched in there is the McLaren MP44, going back to the Senna years,
Right.
with the Honda turbo. And, it's just one of those cars that it's just always, I just love it for nostalgic reasons. And every once in a while, I'll jump onto YouTube because you'll see some of these historic F1 races where they have, and it's kind of unfair too because they have cars from all different eras racing each other, and then you have this one guy in the MP44, one of these, crazy mid '80s cars that was just so much better than everyone else. But it's really wonderful to see them. But we're gonna switch it the course of the conversation now to more of your area of expertise. We already talked about it a little bit before the break there. And one thing that I've always wanted to put to somebody that has the expertise and the knowledge to either prove or explain this or refute it, either way, one way or another, is if you took a Formula One car into a tunnel, could they actually drive on the roof of the tunnel? Is that urban legend, or are the aerodynamics and the downforce generated by a Formula One car that great it could actually drive on the roof of a tunnel upside down?
Not only is that true, but I think you're underselling it a little bit.
Really?
I think the idea most people have is if you got it at top speed in perfect conditions and you just got things perfectly right, maybe it could just hold itself in the air.
Mm-hmm.
That's not accurate. In a Monaco or a Hungary configuration downforce, you could probably generate your own weight and downforce at maybe 120 kilometers per hour, maybe 130. Light fuel and things like that. But if you really, so the short answer is absolutely, it's possible, and it's not even like it's a problem. If you think about an airplane, any kind of airplane generates several times its own weight in lift in order to do maneuvers. Think about an F-22 or an F-16 doing a 9G turn. Well, it turns out that roughly speaking, the number of G's you're pulling in a turn is actually equal to the ratio of the lift you're producing to your own weight. So it shouldn't be surprising that you actually can generate 9 times or 10 times your own weight in aerodynamic force. The question is, how efficient is it, right?
Yeah.
Not only that, but you can do a kinematic analysis. Look at the radius of a corner and how fast the car is going and the amount of downforce that you would be required to have to take that particular corner at that speed. And not only are you generating your own weight and downforce in these configurations, generating somewhere between 3 and 4 times your own weight and downforce. And I think one of the things that gets lost in that equation is, yes, you're generating a lot of aerodynamic force, but also the cars aren't that heavy. They're heavy for us because we're used to these. We're talking about complaining about the weights of the cars recently, but compared to an SUV, it's actually quite light, right?
Bryson.
So, sorry, I was just going to
no, please go on, please.
I was just briefly going to say, not only is this possible, it actually wouldn't even be very hard. The only difficulty is finding a road and a ramp configuration that to do it properly. Maybe you would need an inverted fuel pump for certain situations, but no, that's definitely possible.
Mark, I'm so glad you asked that question because it's something I've wondered forever, but I never wanted to be the person to ask in case the answer wasn't the one that I wanted. So Bryson, thank you so much for that. I want to take it back a couple of steps because I think for those that are new to Formula One, I think we all appreciate, and I think anyone that's familiar with the concept of a road car is familiar with the fact that the power unit is an intrinsic element in producing speed. And I think most people at home understand mechanical grip because they have a road car, they understand, or at least have some cursory understanding of how the suspension components work, the grip that's produced by the tires. But in Formula One, in ways that certainly aren't applicable to a traditional road car, aerodynamics, the aerodynamic properties, the philosophies of the car, they play a significantly more important role than they possibly do in any other motorsport series or with road cars. Maybe talk a little bit about just how critical aerodynamic design is and these kind of functional components of the car are to the performance of the car relative to even other motorsport series. We know about mechanical grip, we know about the power unit, but how important are those aerodynamic elements in enabling the speed and the cornering capabilities of these cars?
I think you hit upon the most important parts of it, which is the cornering ability, but also the braking capability. People don't think about the downforce and how important that is for braking, but it's actually fundamentally important for the braking. The only caveat to what I'm going to say is that this is all circuit dependent, right? How important downforce is different. Are you at Hungary? Are we at Monza? You know, the amount of lap time you gain for having downforce changes for those particular things, number one. But number two, it's incredibly important. When you think about the amount of time that you can gain through a high-speed corner, because there's so much downforce, and again, the downforce increases with the square of the speed. So as you're going faster, you're actually building more downforce. You need more downforce, but you're getting it as well. So you can find a really, really high speed limit. And in fact, a Formula One car can go around a corner flat that a regular car would be struggling to go around at 100 miles an hour slower. They are just incredibly high performance machines. And the amount of time that you actually gain from this downforce is hard to really understand unless you go to a race weekend and watch maybe Porsche Super Cup or a historic series go out and also race. And Porsche Super Cup cars are extremely fast. They will embarrass the fastest of your hyped up hypercars that the boy toys that some of your neighbors might have. And even those are painfully slow compared to a Formula One car. This is kind of why I advocate going to races. It's hard to appreciate how outrageous the performance actually is unless you're seeing it in person. I remember when my dad and I went to our first race together, which is in Austin 2016, I want to say. We were in an area where we could see the end of the back straight. And the thing that caught his eye the most was how incredible the braking was. He says they're coming so fast and they just stop. They just stop like at a point, and you need the aerodynamic downforce in order to do that. The one thing I will say is that you really only need the downforce when you're in a braking event or when you're cornering. It's actually hindering you significantly on the straights. This is why there were active aerodynamic programs developed in the early days, and they were banned eventually by the FAA because the failure mode was spinning around at 180 miles an hour without any warning. But fundamentally, downforce is only hurting you when you're not cornering. We could talk about induced drag specifically, but induced drag is just drag associated with generating lift or downforce in this case. So the more downforce you generate, the more drag you'll create as a result of that. And that's just hurting you on the straights. This is why setting wing level is so critical to the aerodynamic balance of the car in terms of, do I want to be fast in the straights? Do I want to be fast in the corners? And also, this is what makes Formula One special. It's not just the wing configurations, it's the ride height. The ride height is actually far more critical than most people actually recognize. And part of the reason for this is we call the Venturi Effect, is one of the main aerodynamic effects you might have seen before. And it has to do with the acceleration of a flow into a region of low pressure, or conversely, the increase in pressure when the flow slows down, right? A car is traveling over the ground with a very, very low area between it and the ground. So even minuscule changes in ride height have big changes in the minimum throat area. That has a big effect on how fast the flow goes underneath the car and the downforce. So the short answer to your question, which I definitely avoided, is that the downforce is incredibly important for going through the high-speed corners, and it also improves your braking. This is one of the things that, if you ever want to see where very fast guys go faster than you on a racetrack, if you ever race around them in a kart track, usually it's on the brakes. They brake later than you and harder than you, and adding downforce to the equation, adding downforce to the equation only makes it even more pronounced.
So I've got a question for you, Bryson. As excuse me, as an engineer and a Formula One fan, are you a fan or not a fan of the? Well, I guess it's not just a theory because we did see it in Formula One in the early '90s, but the concept of active suspension, which basically optimizes that ride height real time.
Um, I do like active suspension. I do like the idea behind it. You know, it's not even so much changing the roll stiffness or the heave or other aspects of the suspension that I really like. It's actually the ability to actively create a very well controlled platform for the aero. I mentioned how sensitive the downforce of the car is to ride height, not only ride height, but angle. We'll talk about rake at some point, I'm sure. You can control that incredibly finely with an active suspension system, not only for different camber on the road and different, dynamic load conditions. There's so many things you can do. I am a fan of this, but the question is, what do we want Formula One to be? If you have a completely
Right.
unrestricted active suspension system, even though it's not adding power to the car, but if it works the way it's supposed to, we could very easily design and build cars that are undrivable. An unrestricted engineering exercise could produce a car that would break your neck, literally, right? If you let those engineers do what we want to do. So the question is, how far do you want to go in that area?
So when they're cornering, what are the loads that they're currently subject? Well, 4 to 5 lateral Gs. Am I sort of in the ballpark there? Do you think?
I think there's a question between sustained G and instantaneous G. Like
Mhm.
what can you get in a peak versus what can you hold? The same thing in aircraft. It's the same thing.
Yeah.
I've seen instantaneous G of like 6.2, but sustained G probably closer to about 5.2 maximum. And again, it's not just about how much downforce you're making, but is it a high downforce situation and a sustained long high speed corner? There's subtleties there, but I would say that we're firmly in the upper fives for sustained cornering loads.
Bryson, could you, for the benefit of our listeners and me, could you contextualize that a little bit? So, as a point of reference, what would that look like versus combat aircraft or any other kind of ground-based machinery?
It's not quite as much as a combat aircraft, so definitely not. But more importantly, is that the vector of the direction of the acceleration is different in a Formula One
Mhm.
car. It's laterally across you from left to
Right.
right. Whereas in an aircraft, you have the benefit of actually rolling the aircraft and experiencing the G in a vertical axis, which is actually pretty good as long as you can maintain consciousness. Lateral G it's more comfortable for your body. You don't have the same risk of passing out necessarily, but it's incredibly taxing. I don't think
Mhm.
people understand the physical fitness that's required to drive modern cars around modern Tilka era circuits at the speeds they're driving at, and focus and listen to the radio and do all of these ancillary things. So compared to a regular car, I'll give you a great example. I drive a Mitsubishi Lancer Evolution, right?
Okay, cool.
What I consider a decently high performance car.
Mhm.
That car can generate about 1 G, maybe slightly more than 1 G of deceleration maximum. Perfect maximum performance braking. An F1 car has enough aerodynamic drag at top speed and is light enough to experience over 1 G in deceleration just from letting off the throttle.
Wow.
Hmm.
At top speed, letting off the throttle in a Formula One car will produce more deceleration than maximum performance braking in your road car.
Wow.
That's amazing. But also when you see like when you're coming into a corner, I mean, say for example, we're going to be going to Monza in the not too far too distant future. As you go down into the chicane at the end of the start finish straight, which is obviously a very fast piece of track. And just like every other corner in Formula One, you see those markers 150, 150 meters, and that you know that they're waiting to the last moment that they can to start braking. What sort of like G's are they going to be experiencing going into that corner? Because I guess it's going to be those G's are going to be negative. I mean, they're going to want to be pulling the driver out of his seat rather than pushing him into the seat on
But believe it or not,
decelerating,
it's
right?
actually, I hear what you're saying, but believe it or not, empirically, that's actually not what happens.
Really?
Yes. What typically actually happens is because of the way the harnesses are set up, it's
Yep.
trying to actually throw the driver forward.
Yep.
But because the actual harnesses are set up above and behind the shoulders, it does tend to submarine them a little bit. So if you go back and look at the old, 2005, 2006 era drivers, right before they hit the brakes, they will sink into the car actually. But yeah, I mean, in terms of, so it will always, the maximum acceleration that a Formula One car can produce will almost always be under braking and in the early phase of braking. Cornering, you can get pretty high G levels, but the thing is, the car already wants to slow down anyway. You're adding to that. So the theoretical maximum deceleration that you can get is during braking events. One thing I'll also point out, and this is an aerodynamics point, as I mentioned before, the aerodynamic load depends on the square of the speed, right? So the downforce you have, the amount of braking force you can have without locking depends on the speed. So at the very, very early parts of the corner, you can hit the brakes incredibly hard and not lock them. But as you're bleeding off the speed, the car is getting lighter. You have to back off the brake to prevent the wheel from locking. So when you see someone braking into a corner and they're just on the limit of locking the wheel, maybe they're doing cadence braking or whatever it is, that's not a constant brake application. It's hard initially and then backing off slowly in proportion to the square of the speed, roughly. This is why it's so important for drivers to be able to hit braking profiles in their simulator.
Bryson, I have a quick observation and then a question. The first observation is that as a longtime Subaru WRX STI owner, I will let it slide that you own a Mitsubishi Lancer Evolution. But the question I have...
Mark, be nice to the guests, please.
I know, I'm teasing.
No, I asked for it. It's fine.
I love to foster the STI Lancer Evolution rivalry, even though I don't own the car anymore. The second question is, and this is something that we've been getting all season, and clearly we haven't done a sufficient job of answering it, but a couple of terms that have been thrown around in F1 media really since the beginning of the season is this concept of low rake aero philosophy versus high rake aero philosophy. And it ties in well with the concept of ride height, which you were speaking to a couple of moments ago. Maybe speak to or help provide some clarification around the differing philosophies between going with a low rake design versus a high rake design, what that translates into when it comes to the actual practical setup of the car, and how that's impacted some teams detrimentally this year versus other teams where it's been favorable.
Yeah, this is the topic of the day, and it's a wonderful topic. So I'll take one step back before answering that and talk a little bit about the Venturi effect that I mentioned previously.
Sure. I
mentioned that as an airflow accelerates, it loses pressure, specifically static pressure. You can think of this in terms of what we call Bernoulli's equation, which some people find hard to grasp. I think of it more in terms of force equals mass times acceleration, right? If there's lower pressure in front of you than behind you, then you're going to be pushed into that low pressure and you're going to accelerate. That's exactly the same principle behind this. So fundamentally, you want to maximize the velocity underneath the car and minimize the pressure to generate the suction, right? In order to do that, you have to have a wide area ratio, the smallest area at the throat in a ratio to the largest sort of area at the exit. It doesn't have to be physical area, it's an aerodynamic area, depending on if the flow is attached or not. Fundamentally, that ratio of areas, if you can maximize that, you can maximize the suction, or you can minimize the suction peak and generate maximum downforce. The issue with the rake is the more the rake angle is increased, the higher the exit area effectively is, so that the ratio of the maximum area to minimum area is bigger, and you can work the floor a little bit harder. The issue typically is you get more leakage and suction from the sides of the floor, right? The more the floor is off of the ground, and again, it's low pressure underneath the floor, you have more or less ambient pressure around the sides. It's going to try to leak in, ruining that beautiful low pressure region that you've been trying to create. So a lower rake floor can, in general, be a little bit more stable, a little bit less peaky in terms of the downforce, but it requires you to have maybe a little bit more area, work the area a little bit differently. What we didn't realize with the 2021 regulations in rake, we were thinking about the sides of the floor and the front of the floor. We weren't really thinking about the back of the floor. We expected the high rake cars to suffer because of that more leakage around the sides, as I mentioned. What we didn't realize is the actual rear brake drums and the winglets that sort of grow out from that have a mutually beneficial relationship with the diffuser. And because the wheels themselves aren't moving, but the car is moving up, you're decreasing the proximity of those winglets in the rear brake ducts and the diffuser. And it's actually enhancing the diffuser and letting it work better, is what's actually happening. So when you actually cut those corners away from the rear part of the floor for the lower rake cars, they no longer have the same real estate to generate the downforce that they want, and they may not have the same minimum pressure that you would get with a high rake car. But not only that, they're trying to figure out a way to take a low rake philosophy and sort of modify it to make it run in a high rake configuration. The reason why that's so difficult is that it's not as simple as just jacking up the rear of the car, because the angle is formed by the height and the length. The wheelbase is what really matters. And we know that Mercedes has a significantly longer wheelbase than Red Bull does. And you can see this if you ever look at the two cars side by side. Not only is the high rake angle in the Red Bull generated by rear ride height, it's also generated by a very short wheelbase compared to other cars. So I know it's still too long. We can get into that. But compared to other cars, it's actually a very short wheelbase. So if you try to take a Mercedes with a long wheelbase and just try to jack it up, not only will the angles not match what you're trying to achieve, but also you've designed a body, you've designed a nose and a certain angle and where the wing is at the front of the car. Jacking up the rear of the car lowers the nose into a region that's not acceptable. And in fact, one of the things we talked about, maybe have been offline, was one of the parts of the nose, the wing that's most sensitive to the wake of a car in front is the center of the wing. And the closer it gets to the ground, the worse it is. So these are things that we're trying to avoid. And if you talk about the 2022 regulations, we're going to have to say goodbye to our old friend, the Y250 Vortex. We have a neutral section of the current wings. It's from the lateral center line to the lateral 250 millimeters either way, where it's an aerodynamically neutral part of the wing. And then the actual wing starts in a high lift sort of situation. From aerodynamic theory, you can actually tell that the vorticity shed downstream depends on how aggressively you change the lift from one part of the wing to the other. If you're landing in an aircraft and you see the flaps deployed, for example, You'll see a big vortex coming off of the flap. It doesn't occur at the wingtip. It occurs at the flap because that's where the biggest jump in the loading is. So the Y250 Vortex, what you've been using and exploiting to make the barge boards and the floor work harder, is actually explicitly being designed out of the 2022 regulations by the wing design, which we can get into, but that's the longish answer to your question.
Well, I think that's, sorry, go ahead, Mark.
No, please go ahead.
I was going to say, I think that's a great place just to leave it, because there's a number of things I want to pick up on. So we'll take a short break here. When we come back, I really want to get your take on what we've seen as a concept of the potential 2022 cars and the aero and everything like that. So we'll do that here on the flip side after we take a short break for a message from our sponsors. So please don't go away. We'll be right back. Okay, well, welcome back to the show. We're sitting here discussing all things Formula One. Specifically, we've been talking a lot about aerodynamics with our special guest, Mr. Bryson Sullivan at Natural Paradigm on Twitter. And Bryson, you left it dangling there just before the break, and just what we've seen coming potentially for 2022. And I know that what we've seen is just a mock-up of potentially what we could see on the track next year, but to your educated eye, to your trained eye, what was it that you picked up? What were some of your takeaways when we saw this scale mock-up released about 6 weeks or 2 months ago?
It's very clear, especially looking at the rear wing, that the intent is to take the regular weight coming off the cars and to push it upwards higher, and to also draw in air from the sides of the car, air that has a higher stagnation pressure, higher energy. You could think of something that would be less detrimental to the car behind. It looks a bit odd to me. I'm always going to feel odd about rear wing end plates that aren't perfectly vertical, but I can see how they're guiding flow from the sides and pushing the wake further upwards. One of the things that I would try to convey that isn't really talked about enough is why an aerodynamic toe is as powerful as it is, and really what it is, right? There's often a lot of talk of turbulent air, dirty air, turbulent air, hot turbulent air. Those are all true. And in fact, there's an angularity effect that also reduces downforce in certain situations. But the most salient effect of the wake, in my mind, is actually a drift velocity. And what I mean by that is, if you're looking at a stationary point and a car drives by, the air is chasing the car behind it. right? We think of drag as the force backwards on the car, but by Newton's second law, that by definition is the force going forward on the air. When the air goes by, the car goes by, air is going along behind it. When you drive into that, the relative velocity of you and the air is now lower, right? Because you're driving into air that's moving away from you, by definition. The aerodynamic downforce you create is not a function of how fast you're going in absolute terms. It's a function of how fast you're going relative to the air mass. This is why airplanes always take off into a headwind, because you want to get airborne as quickly as possible. It doesn't matter what your ground speed is. What matters is your airspeed. So functionally, the issue with the wake is, yes, there's lower pressure behind the car in front. That's definitely true. But that pressure field is pretty localized around the car itself, and it equalizes to ambient pressure in maybe 2 or 3 car lengths. But that drift velocity that I mentioned, that going along in the same direction as the car, and if you're generating downforce, there's spinning vortices behind, those last much longer. And those are actually, I would say, the primary reason why the car is being robbed of downforce. You're being robbed of dynamic pressure because your relative velocity compared to the air mass is now lower, fundamentally. So in terms of the 2022 car, things that you want to do are, first of all, clean up the bodywork. This is what I saw. Clean up the bodywork of the car to be less disruptive in general, but also as a primary thing, direct the wake of the car upwards more and bring in more clean air from the sides so that the car falling behind will have a less difficult time. But one other thing I would say is, this is the caveat for all things, the FIA and the teams are in a relationship that is not it's not a relationship that is based on mutual trust. The FIA is trying to prevent the teams from doing certain things, and the teams are doing everything in their power to subvert the spirit of the regulations, if not the letter. Right?
100%.
So even when we see the rather awesome aerodynamic figures from the FIA saying you can retain 85% of your downforce at 2 or 3 car lengths behind, you're not going to get quite that level of performance because the teams are going to actively disrupt it, not only for themselves to improve their own downforce, but they have a vested interest in ruining the airflow of the car behind, despite what the regulations say.
Yeah, for sure. I mean, that's what we as fans want to see, is the opportunity for cars to draft to get close to the car in front of them, and then in theory have the opportunity for more overtaking. But you make a great point, and I never really thought of it, but it is so obvious. Of course, they want to be able to punch a hole in the air more efficiently, and they also want to spoil it as much as they possibly can for the car behind them. I think that's a very, very astute observation. And the whole concept of tow I always find very, very interesting, because I'm a road cyclist, and I was out this afternoon after work riding. And the one thing I always find very interesting is when you're riding in a group of riders, is the guy at the front is always going to be doing the hardest work. But it's an interesting phenomena, because it's I guess it's similar, but on a very much reduced scale compared to motor racing, where the cyclist in front is punching the hole and pulling the guys behind him, but the riders behind are to a certain extent pushing the riders in front of them. Of course, like I say, the guy at the front is doing all the work, but from sort of maybe extrapolating a little bit and sort of bridging over into motor racing terms, do we see that effect too? How does the aerodynamic effect of the following car affect the car in front of them? Like, is there any effect on that?
Generally speaking, there's always going to be an effect in a subsonic flow, right?
Okay.
I don't want to get too specific about it, but what defines a supersonic flow is the ability to not communicate information upstream. So theoretically, in any flow situation, there's always going to be some upstream influence on the car in front, and even on the car itself. Modifying the rear wing of your car can affect what's going on at the front wing, actually, because there's upstream influence. There's definitely an element of that in Formula One, but it's much more one way than the other way. If I were to do it percentage-wise, I would say in cycling, it could be, 85-15 or 90-10. In an F1, it would probably be even a little bit less than that.
Okay.
It's almost entirely the front car disrupting the air for the car behind. Now, a similar idea, not the same idea, happens when you have a DRS train, for example. We talk about DRS as an aerodynamic device to reduce the drag of the car behind. It's primarily induced drag, but reduce the drag of the car behind, allow them to sort of accelerate past the car in front, maybe 10, 20 kph relative difference in maximum speed, affect the pass, and be successful. The problem is, if someone is in front of that car as well, then the car you're trying to pass also has DRS, which neutralizes your own DRS. So even though you have these devices which are designed to be able to help cars pass each other, by their very nature, if you have a large number of cars together, it can cause a problem. That being said, a long train of cars, and you see this in NASCAR and other series as well, a long train of cars actually has improving benefits the further back you go. Remember what I said about the relative air velocity? One car goes through and there's a drift velocity behind it. Another car goes through and it also pulls some air in behind it. By the time you get a fourth or a fifth car going by, there's a wide region of moving air that's not the same velocity as the free stream air that the car in the back can drive in and actually have some margin left and right and still be within that pocket. So there's a compounding effect with more vehicles in general. But yes, the effect is definitely there, and it's primarily front to back as opposed to back to front.
Bryson, we have some really fantastic listener questions that I'm dying to get to, and I know they are as well. But I wanted to ask this question just while we're on the topic of the 2022 car. Back in the early 1980s, the FIA, much to the chagrin of a number of teams, banned the use of ground effects, underbody ground effects. And I think one of the things that surprises a lot of people that are new to Formula One, but are familiar with motorsports and motorsports aero design philosophy, is you look at even some high-end road cars like a Nissan Skyline GTR, which has a significant amount of underbody aerodynamic functionality. And they look at the bottom of an F1 car and it's basically just a flat plate. Talk about why, if you will, ground effects were taken out of Formula One, and why is it now that they're being reintroduced?
So the biggest problem that we had in ground effect previously, especially with the skirts that were sort of actively being modulated in their height to maintain a physical contact with the ground, is if there's some reason why those skirts aren't actually able to maintain the pressure differential, maybe you go over a curb in a weird way or they get stuck, you don't just lose a little bit of downforce, you lose a ton of downforce, and you lose it in a way that's unpredictable, in a way that is liable to produce high speed and dangerous accidents. Essentially, the reason why the ground effect was removed in the past is kind of the argument behind the fan car as well, the famous fan car, is that the failure modes are catastrophic. It was getting to the point where the cars were going around the corner incredibly fast when they were hooked up and everything was working perfectly. But if they were slightly off kilter, or if the situation was not perfectly optimal, you don't lose the downforce gradually. It's a snap change, and that results in a big crash. Why is it better for us to go back to ground effect now? It has to do with aerodynamic efficiency, which is basically the amount of lift you can create for even amount of drag, or vice versa. Maximum efficiency is maximum lift to drag ratio, right? It turns out that not only is underbody aerodynamics less sensitive to disruption in the wake from the car in front, but it's also more efficient in terms of lift to drag ratio. Both of those things are excellent if you're trying to maximize overtaking capabilities. You don't want to be affected by the car in front, and you also don't want it to affect the car behind too much, right? So relying on the ground effect is better, and there are ways in which I'm not going to say I've learned personally, the people who matter have learned ways to aerodynamically tailor the design of the Venturi channels underneath the car and the entire car in general to have a much more gradual change in downforce as a function of ride height and going over bumps and all these other things. It will be far more safe now than it was then. But the upshot is relying more on underbody aerodynamics provides a less aero-dependent formula, which is to say, you can maybe still recover some of the similar downforce levels in free air, but you're also not affected anywhere near as much when you're behind another car.
You know, just before we throw it to another break here, I have another question for you, Bryson. When somebody who knows what to look for when it comes to the aerodynamics on the car sees what, these zebra paint jobs that they throw on the cars in preseason testing, because we see the picture, it does take away some of the depth. But is that effect really that noticeable? If you see the RB16 or the RB16B or whatever they're running this year, and you see it in its normal livery, and then also this zebra version, does it really dull the effect that much? And how much can you take away from a still photograph from a Formula One car, and really what can you really derive from a photo in terms of what the aerodynamics are doing? I guess that's what I'm driving towards.
The zebra effect is helpful if the number of pictures you have is limited. If you
Okay.
have enough pictures from enough different angles, you can piece it together, what's kind of
Okay.
going on. This is probably more applicable to road cars than F1 specifically. It does help a bit, but people who kind of know what to look for and can look for edges can kind of figure it out. I'm not quite at that level of expertise yet where I'm digging through a massive number of pictures. But people definitely can do it. On the other side, we haven't talked about flow visualization paint before. If you ever see the
Yep.
green sort of chartreuse sort of colored paint slathered on the car in all sorts of various areas, fundamentally what that's doing is looking for flow separations. When the airflow is being worked appropriately and it's being worked as hard as it can for maximum downforce, it's following the contours of the car.
Mhm.
But if you work the air too hard, if what we call adverse pressure gradient is too severe and the flow separates, you will lose a lot of the downforce and you'll increase the drag as well. But there'll be a visual trace of it in the actual streamlines on the surface. So that's something we can get into a bit later if you'd like. But fundamentally, it's another way that aerodynamics can be observed directly, although not very quickly, and you have to clean it off later.
Yeah, of course, nowadays the wind tunnel time that they have is limited and those sorts of things. But that paint compared to a wind tunnel, are you going to get and observe different things going on with the car, one method compared to the other?
You definitely can, and the biggest difference is scale, right? So you cannot test a full scale car in the wind tunnel because there
Right.
are cost considerations. You usually test, I want to say, a 1/6 size car if you have a rolling tunnel. I don't remember maybe it's even a 1/2 size. I don't remember what the exact size is, but that impacts something called Reynolds number. Reynolds number is effectively a ratio of inertial forces to viscous forces. It basically tells you how important viscosity is in a given situation. It tells you, in most situations, it will help dictate whether or not a flow can actually remain attached to a surface or not. So it turns out that the exact same geometry running at the exact same physical speed may behave slightly differently at a smaller scale than a bigger scale, only because of this Reynolds number effect. You can account for this by making modifications in the wind tunnel. This is why we have lift coefficient is far more important than lift itself. Lift coefficient is dimensionless. And from a theoretical perspective, the lift coefficient will not change as long as the Mach number, Reynolds number, and geometry are the same. You can map small to big as long as you get all those three numbers correctly modified. But fundamentally, yes, there can be differences. And that's why it is always important to test on track. It's always important to run these big rakes of pitot tubes in order to do correlation of the flow structures that you see in the real car versus other things. And then the final point is, this is kind of a academic point, but a Formula One car is an accelerating reference frame. And what I mean by that is, if I have some sort of a vortex and I'm in a corner and it's generated, the trace of that vortex will curve. It's going, you're driving around a curve. It makes sense that the vortex will curve. But if I'm in a wind tunnel and I just angle the car at 5 degrees sidestep angle and I make a vortex, the vortex goes straight back, right? So there's actually a fundamental difference in the way vortices and flow structures behave in accelerating reference frames, which is what the car actually is, versus in the wind tunnel and just changing the angle. The only thing that can really simulate that at the highest fidelity is actually computational fluid dynamics, CFD. And even then, we oftentimes just simulate half the car and rotate it at an angle. But there are fundamental differences that you can get between wind tunnel, CFD, and road testing, that all three of them have to work together to come up with a real solution.
Cool. I was going to ask another question, but I think people are probably going to be taking a running tally of how many questions I've asked of you already, Bryson. So
No, it's fine.
what we're going to do is we'll take a quick break, and then Mark has lined up a bunch of listener questions that we want to throw at you. And then, of course, we've got news. We've got a race this weekend, so we've definitely got to make time to touch on all these subjects and topics, and we'll do that starting in just a moment after we take a short break. So please don't go away. We'll be right back. Okay, well, welcome back to the show. And now it's the time that Mark hinted to a long time ago. It's taken us a little bit of time to get here, but better late than never. And we've certainly learned a lot of things. I had a couple of things I wanted to ask you, and I should have written it down because I've completely forgotten now, and it'll come back to me eventually. Anyways, mailbag time. So we'll start off with the first question. These are all from Twitter. So the first one is from Bengal Hugger. And the question is, what, if any, aero design did Williams run to hold so much downforce in the ring compared to other cars this week? Was Russell's qualifying performance overall car setup, or just George being George?
Yeah, that was an incredible performance, wasn't
it?
Yep.
Yeah.
So, first of all, hats off to George. He had an outrageous lap. He had tremendous confidence through Eau Rouge and Radeon that gained him maybe 4 or 5 tenths when you consider the time at the end of the straight. But he was helped with car setup. And aerodynamically speaking, the amount of downforce or lift that a wing creates in raw numbers depends on how big it is, right? How curved it is, which you call camber, and the angle of attack, right? Right away, when George finished his lap and I looked at the actual car, you could tell that there's a huge difference in wing design between that Williams and the Red Bull. Now, of course, the caveat is the Red Bull has a much more efficient floor. They can generate a bigger fraction of their downforce with the floor. They don't need as big of a wing to have the overall level of downforce. But I wouldn't surprise me at all if Williams had more downforce than you might otherwise want in a dry configuration, assuming that it was going to be wet and maximizing their chances, because downforce, the benefit that downforce gets you is kind of exponential in the wet. So it really helps you out a lot. In terms of the lap, yeah, George just had a phenomenal lap, and hats off to him.
That was great to see, wasn't it?
Oh,
okay, Mark, take it away. Next question.
Next question, Mr. N at NKJ05. And I thought this was a really interesting question. If car size was reduced to make for better racing, presumably more compact cars create more space on the track for overtaking. But if car size was reduced to make for better racing, i.e. max length 4.5 meters or width of 1.6 meters, what would the aero departments at the individual teams need to do to keep the cars as fast as they are today? Or would that even be, I'm adding this last piece, but would that even be possible with a smaller package?
Yeah, I mean, so it depends on what the FIA will allow you to do. So fundamentally, if you have less real estate to work with as far as making a low pressure zone to sort of suck the car to the track, if the real estate becomes smaller, that means you have to work that floor harder. You can use a more aggressive diffuser. You can have more crazy barge boards if they were in the regulations. It's not beyond the realm of possibility to work the floor harder and use different wing designs to make up some of that difference. But as far as the cars being smaller, it's a beautiful vehicle dynamics question, actually, because even if the overall downforce is less, the car is smaller too, and it has different mass properties. It may not be much lighter, but it may be slightly lighter. So what actually matters in terms of car performance isn't so much raw downforce in kilonewtons or whatever have you. It's actually the ratio of the downforce to the weight of the car that really sets things. So if for some reason they were to reduce the minimum weight limit or do some other things, you could actually get similar performance to what we have now. But I think the goal is primarily about improving the raceability of the cars. And one point that I mentioned, I think it was a couple of days ago, is that with less downforce for 2022, the overall lap times will definitely be slower. But less downforce, by definition, means less drag, right? With the same engines means you may have higher top speeds. So look out for Monza, look out for a few other places. You may see some, Mexico, especially because of the low density, high altitude. You may see some record top speeds next year.
That's very much an unreported knock-on effect of the formula change for 2022 and not something that I've seen referenced anywhere, but you're absolutely right.
Yeah, the only caveat there, of course, is I don't know what the baseline drag coefficient is. So you're going to have less induced drag, but I don't know what your other components of drag are. And if it's just a very, very draggy car, which I doubt, but if it is, those are competing effects that could conflict with each other. But we'll see. I'm optimistic that something will happen next year. It will be entertaining. I'm not sure what it is though.
I think that's you've nailed it, because I think that we all have all these big questions, big expectations, and it's going to be fascinating to see how this theory translates into design and into the cars that get built and run next year. Okay, next question comes from George C. And he says, I saw a picture that showed the RBR cars with different looking aero packages / bodies. My question would be, why would RBR not build the same aero packages, and how the drivers would be involved in the design? Also, what effects are the different aero packages?
So the answer to that is that there are two different types of aero related things. One would be downforce. The other one would be cooling, really, right? So maybe one driver likes to have their car with a higher rake, maybe higher overall downforce, but a little bit more peaky, a la Max Verstappen. Or maybe Checo likes to have maybe a little bit less raw downforce, but for it to be a little bit more stable. That's an aerodynamic difference, maybe more wing, less wing. That's why you could have an example of differences between those two. But the other question is about cooling, and that actually could be to do with where you predict the driver to be over the course of the weekend. This question that I mentioned before about being in the relative wake of a car and having lower velocity, that affects cooling as well, because you need velocity going over the car to maximize the heat extracted from the engine. If you're going to be stuck behind other cars the entire rest of the day, you're going to need to get more air into the car than you otherwise would, because the air you're already receiving is at an elevated temperature. So, for example, if I saw Sergio Perez's car with sort of wide radiator outlets at the back of the car, bigger than Max Verstappen's, one possible explanation for that could be they expect him to be in traffic and to need to drive around other cars and to follow them close in their tow. There may be elevated temperatures there that they want to have some margin for, some thermal margin. That's definitely one thing. Sometimes they just can't make parts. Also, Red Bull has been pushing the boundary of development, and I know they're not. They're by no means strapped for cash, as others have pointed out. But the physical amount of time that it takes to manufacture something, when you're on that bleeding edge of a level of development, sometimes you can't always have something ready. And in fact, it's a point of contention and controversy as to whether or not Checo races the same specification of car that Max does. The answer is no. But the underlying question is, why are they different? So that's a whole other topic we could get into that's not technical, but still very interesting.
Building on the theme of Red Bull, our next question comes from Michelle. And her question is, and this ties back to a couple of other points that you've spoken to a few moments ago, but her question is, if Red Bull is being so successful with their current high downforce philosophy, why doesn't Mercedes simply run it as well? Especially since they were complaining that the new regulations hurt the low rake cars. Is it too hard to change mid-season?
Fundamentally, yeah, it is hard. And this gets back to the question of wheelbase that I mentioned before. I don't have the exact numbers in front of me, but the Mercedes wheelbase is substantially larger than the Red Bull wheelbase. That's something you can't change mid-season. You can change how you run your car. You can change if you're running it higher at the back, but fundamentally, there are certain dimensions of your design that are impossible to change this late in the game. So the short answer is it's just not easy to change. And secondly, Mercedes has their own philosophy. They'd be wading into uncharted territory if they just tried to purely replicate what Red Bull does. This is what Racing Point found out with their RP20, the pink Mercedes. They had a perfect copy of the W10 initially, and it didn't work in the wind tunnel. And they couldn't understand why and had to tweak it and modify it to be slightly different in order to actually understand what it was doing. So you can't, as much fun as we like to say that you can just copy someone else's things, Mother Nature knows the difference. If you didn't do it perfectly, it won't actually work.
I guess the perfect comparison in the aerospace world would be the Concorde and the Tupolev. One was a copy of the other, right?
I have more love for the Tupolev than most people might. I enjoy the canard design. I like some of the aspects of it. It didn't use the Augiv wing. It used a cranked wing, which I like. it has some problems. We're well aware of that, but you're right. And again, I don't want to do too much defending of the Russian Federation in this particular podcast. But what I will say is there is such a thing. There is such a thing as convergent design.
Yep.
It's the same laws of physics for everyone, and the optimal solution is whatever it is. Okay. So even if you wanted to design something different, sometimes you can't because it's clearly not as good.
All right. And finally, this is a bit of a big one, and this one will take us into our last break, and then we can focus on some of the more contemporary and up-to-date news in the race this weekend. But Diego R asks, will you guys talk about the whole RBR and Mercedes engine thing that is going on? What's the
great
controversy? Who's being accused of what?
Yeah, very juicy. So this is not a theoretical debate. This has actually resulted in Red Bull requesting an FIA clarification as of this week. Fundamentally, what Red Bull is asking for clarification on from the FIA is whether or not Mercedes is cooling the flow into the intake plenum more than they're allowed to. Okay, so think about how a turbocharged engine works. The air comes in at ambient pressure and temperature. It's compressed with a compressor. The pressure and temperature rise to some high level. That flow then goes through an intercooler to lower the temperature but keep the pressure, roughly the same. A colder flow at the same pressure is a more dense flow. You can fit more kilograms of air per cubic meter in the space. If you can put more air in the space, you can put more fuel in the space, and therefore you can generate more power. So the colder you can make that intake flow, the better it's going to be. I believe they're limited to 10 degrees below ambient temperature. And of course, there's a sensor in the engine that's measuring what the temperature actually is. The charge, in my understanding, is from Red Bull is that Mercedes is doing something a little tricky with their engine, overcooling it in certain acceleration phases of the corner more than they're allowed to. How they would know this, I have no idea. But there's also some suggestion that the actual placement of the sensor is in a particular location that doesn't give exactly a representative number for what the actual inlet temperature is. So not only are they suggesting that they're doing something untoward with their cooling of the intake charge air, but also that the measurement is wrong, where it's not representative of what the flow is actually doing.
So there's a bit of sleight of hand going on then.
I don't know. So if they've asked for a clarification, something is definitely going on. The question is it legal or not? Chances are it probably is legal. And even if there is a clarification, typically this is something, it's not cynical, but it's actually accurate. When someone asks for a clarification, they're not actually trying to stop their rival. They're actually trying to do it themselves and get something on paper saying, okay, I'm going to do this. This is legal. You said so, right? So Red Bull, if they're finding out this is accurate, they're going to want to be doing this themselves. The problem is how many more, you can't do performance-based changes to your engine right now. You can do reliability things and you can do a couple of things, but they're very limited in what they could actually do in response to this, even if Mercedes were actually doing it. The only thing they can do is if there's a breach of a regulation, they can make Mercedes stop. But
yeah, it's an interesting discussion to have, because if say, for example, and Mercedes is doing something that is not permitted, then they should be made to comply, and if there's a penalty involved, then so be it. And if a team, Ferrari, for example, which we've talked about many times on the show, it was, they got busted for something, which we all have a pretty good idea of what it is at this point in time. And we've had that discussion as well. But just the whole Mercedes and Red Bull thing, I don't mind this sort of shenanigans, if you want to say it or put it that way, as much as the whole fallout from the British Grand Prix. Yes, I get it that you were upset that your car was put out by Lewis Hamilton. It affected the title race and everything like that. But the reaction and the things that Red Bull were saying, I felt went on too long, and I felt ultimately it was disproportionate to what happened. Like, sure, you're upset. It happened, and just all the suggestions that and I'm not trying to be a Lewis homer here. I'm trying to just be neutral about it.
right.
But I felt that I thought it was too much for too long.
There are days, some days more than others, where I wonder what Niki Lauda would say about a given situation.
Great
and
point.
The saga between Red Bull and Mercedes after Silverstone, I just think Niki would have gone to the motorhome and said, listen, that was a racing incident, or maybe it wasn't. Your driver is okay. The chances of you successfully lobbying against the FIA, because remember, the Red Bull's response isn't actually to Mercedes. They're actually saying the FIA did something wrong. They didn't penalize them enough. For the FIA to go on against themselves and say, no, we did something wrong, would require extraordinary evidence of the highest order to convince them, right?
Absolutely.
And it also would require not manufacturing data. It would require finding data that was already there. You cannot custom enlist Alex Albon to reproduce lines in your own car, which is not the same as the Mercedes car. The data isn't actually comparable.
That was the flimsiest thing ever.
It's also a waste of Alex Albon's time, I think. But to the wider point, yes, I believe that was gone too far. Some of the comments made were of an incendiary nature that actually questioned the racing integrity of Lewis Hamilton in a way that I think was unjustified. I think many people would argue that as well. And the furor that it generated in the wake of that had very real world consequences that we don't have to get into now, but suffice it to say they were negative. I think Red Bull could have done a better job with that particular episode.
Yeah, I totally agree with you. And the firestorm that generated from the comments, they said, it pushed it to what I felt was beyond what was sportsmanship, and almost got to the point where I felt it was becoming irresponsible, just because the like you say, the negative things that spun off from that were, you just don't want to see that at any point, right?
And I know we have to cut to a break, but I think Bryson's touching on something that we discussed at length, which was those type of incendiary, unnecessary comments. They tend to activate a portion of the fan base or society that is irrelevant to Formula One in this community, and they look for an opportunity to spew negativity and hate when it's unnecessary. And for me, I think that's what was so problematic. And we've talked about this before, about that entire situation, was it activated a segment of society that we didn't want to hear from, that Lewis did not necessarily need or wanted to be exposed to. It was unnecessary, and it was damaging to the sport. And it's not helpful when you're trying to cultivate and nurture a diverse fan base. It was very, very problematic in my eyes.
Yeah, absolutely. Well, guys, why don't we move on from here? We'll take one final break, and we'll come back and we'll talk about things hopefully a little bit more positive, something a little bit more exciting. Yeah, talking about the Iceman retiring after about 75 years in Formula One, so end of an era for sure. And we'll do that in just a moment. So, guys, don't go away. We'll be right back. All right. Well, welcome back to the show, and Bryson Sullivan joining us again for one final segment. Really, it's funny. There's I was checking the YouTube live stream, and one of the comments that we had from Charlie Tinkler said 30 minutes in, and I've had to Google 40 words so far. So
that's a compliment.
Hopefully, this has been as educational as it has been enjoyable for everybody. But as I said just before the break, it's the end of an era in Formula One as Kimi Raikkonen, the 41-year-old, announced his retirement from the sport earlier this week. And I guess, guys, we could see this one coming just based on his age and the fact that he's slowly kind of migrated down through the field over the past several years, currently racing with Alfa Romeo. We had a question from Vincent, and he says, I highly respect him, but I don't get all the love for Kimi. Do people like his coldness, like the one form the Queen of England has? A reassuring, unfriendly face that never changed throughout history. Please explain. So I guess there's the question about the Iceman, and the fact that his answers to almost everything are limited to just basically one syllable and the fewest words as possible. But maybe more than that, what do you guys think is Kimi's legacy, walking away from Formula One for not the first, but actually the second time, because he did take a couple of years away from the sport about 10 years ago after he won his championship, raced in WRC, even had a one-off in, was it NASCAR as well, or did some testing, I think, with Jeff Gordon. I think he drove in the truck series as well. So came back, obviously not quite as successful, but still quite a career.
Bryson, I'm dying to hear you reflect on his career. Like you said earlier in the show, you joined the Formula One community back in 2005. He was still a relatively young driver. reflect on his career. What will you remember of Kimi? Where does he sit amongst all the all-time greats? He is a World Drivers' Championship. Would love to know your thoughts.
There's only one Kimi Raikkonen, right?
Yep.
That's where I would start. Now, I heard the comments about a cold character and someone who's unfriendly. I wouldn't interpret his behavior in that way. He's just Kimi. He there's no way to describe him other than he is what he is. When he was younger, he was maligned for being so young and being so inexperienced when he came up. But right away, he was fast. Some of the same criticisms that Max Verstappen actually got when he first started. Not enough experience, too young. I don't want to say Kimi was the original Max because they're very different people with very different skill sets and things. But Kimi showed very early on that he had the pace at Sauber, and that got him a seat in McLaren. He would have won the championship earlier were it not for serious reliability issues.
Yep.
Maybe a wing failure at the Nürburgring here or there, who knows, or suspension failure. Who knows what could have happened in his career, but he was blindingly fast. Of course, he became more of a walking, talking meme in his time, but he's a great character in the paddock. He knows a lot about racing, and I will be sad to see him go.
Mark, what's your take on Kimi Raikkonen and his legacy?
Yeah, there's a personal dynamic or a personal angle to this, which is I had the terrifying realization today that I am now older than every driver on the Formula One grid. And when I realized that the 41-year-old Kimi Raikkonen was retiring, I desperately grasped at my phone and Googled age of Fernando Alonso to discover that I am, in fact, 5 months older than him. So that was a kind of a personal dimension to all of this. But it is interesting, and I'll share another personal story. I still remember back in 2001, I was in the UK, and I remember walking through a supermarket. I think it was Tesco, and there was a copy of F1 Racing magazine on the shelf, and it was that famous photo of Kimi standing. He's got a big smile on his face, which you typically don't see in a produced photo shoot anymore. And the cover was Ferrari's next world champion. And ultimately, he may not have been their next world champion. Of course, he did win a world championship for them. But I remember looking at this and thinking, this is typical British tabloid meander, thinking this is never going to happen. They're overselling this kid. And 6 years later, I couldn't have been proven more wrong. But I think Bryson's absolutely right. There's one Kimi, and I think he appeals to a lot of people just because he doesn't have a manufactured persona. He clearly doesn't have handlers that are feeding him lines. He's not trying to appeal to the broadest possible demographic in interviews. And I think people respect that and appreciate that. And he's cold, and he's often comes across as unfriendly or inaccessible. But I think people appreciate the authenticity. And in terms of what Bryson was speaking to, you're right. Like in 2003, he was a hair away from a championship that year, if not for the fact that he ran into some reliability issues. And in 2007, you could say maybe he was in the right place at the right time because, of course, the two Mercedes drivers that year were so evenly matched, and they kind of split the difference and allowed him to sneak up the middle and take that championship. But any championship's well-deserved. But I think for me, the moment of his career that will always be most memorable was that 2012 win for Lotus at the Abu Dhabi GP. And that overshadows in a way his win in Australia the following year in very much the same car. But for him to come back to Formula One with that team that had such small expectations in the grand scheme of the sport, and to just rack up points and steal away so much money from that team in the term of performance bonuses, I think this is sad. I think it's due. I think we'll all reflect back on his final win in Austin in 2018 as an important moment. But I think it's time. But obviously, he'll have competed in a third of all Formula One Grand Prix, 350 by the end of his career. It's a remarkable journey, and I'm very excited and happy for him that he's able to retire as a champion.
Yeah, for sure.
I just wish him the best in his future endeavors.
Absolutely.
Yeah. He hasn't really committed to anything. I know there's been some speculation that he might drive an Indy next year, but the most recent comments I saw from him earlier today was that he's not really looking beyond, focusing and spending time with his family. But just going back to his whole persona and things like that, and the fact, and I kind of get. I like Kimi being Kimi, but also just based on the fact that, I've interviewed a lot of professional athletes, and he's completely different in many senses. And I think going back all those years to the time, I think Pele was giving Michael Schumacher an award, And Martin Brundle asked Kimi why he missed the ceremony. And well, I'm not going to say exactly what Kimi said, but he basically said he missed it because he was in the bathroom. And you guys can take it from there. Anyways,
words that will live in infamy.
Certainly. All right. So the next one, and this is obviously another hot topic. So George Russell says he knows where he'll drive in 2022, and Valtteri Bottas wants a multi-year deal wherever he ends up. So reading between the lines, I think that whatever's been arranged for these two drivers regarding these, both of them and where they're going to be, I think that this is well known behind the scenes, and that the powers that be are just waiting for the right moment to announce it. But Mark, maybe you want to take this one away, because there's been some interesting speculation that's been floating around. I mean, obviously George is pretty much the heir apparent to Valtteri Bottas at Mercedes, but some of the unexpected, maybe you want to call them knock-ons from there in terms of this driver movement.
We've been talking for weeks about the fact that eventually a domino was going to fall, and that domino, I think, really is Kimi in so many ways, because I think obviously Mercedes is aware and knows internally. I think their press corps, I think the factory, I think their front office, everyone involved in that organization knows what the driver change is going to be there. But I don't think that Toto, out of respect and as a professional courtesy to Valtteri Bottas, is ready to make that announcement until he's helped ensure that Valtteri secures a drive. And I think from Valtteri's perspective, I think he's stating publicly that he wants a multi-year deal. We know that's something he's never had with Mercedes since he joined the team for the 2017 season.
Which he
not
totally
had.
Deserves.
I completely agree. He, at this point in his career, if he has the opportunity to acquire that level of security, he deserves it. I can't imagine what it's like to race and compete at the highest level of Formula One, knowing that you're racing on a year-to-year deal. That lack of security is challenging, I would assume, mentally, philosophically. So I think we all know, and we can get into the dynamics and kind of the more granular nature of what's probably going to happen. But I think Kimi retiring opens up a seat at Alfa Romeo, and I think we all have every reason to believe that that's probably going to be filled by Valtteri Bottas, and I think it would be a good fit. And if he can secure a 2-year deal, that's fantastic, because it creates an opportunity for George Russell at Mercedes. And then there's presumably a whole bunch of additional dominoes that will fall and changes that will happen. But Bryson, from your perspective, does that seem like a logical transition for a Mercedes driver to partner with Alfa Romeo? Does that seem like a good marriage? And ultimately, from your perspective, is George a good fit for Mercedes?
I do believe we go in reverse order. I believe George is a good fit, and he actually convinced me of that in Sakir last year. I believe he was faster than he had any right to be, frankly, given his problems physically fitting in the car, all of the factors involved in that particular weekend. Right then, I believe the decision should have been made to seriously consider him in the car, and his performances since then have only improved. So yes, I believe he's earned that position. As far as Valtteri to Alpha, that makes sense to me. And I would also just highlight the fact that the Alfa Romeo branding of the team, which is actually Sauber, is a licensing deal for the name. It's Sauber, right? Sauber and Mercedes have kind of a long and storied history in Le Mans with the C9, and even in Formula One in Sauber's early days. It's not beyond the realm of possibility that Alfa Romeo currently, which is Sauber, could in fact switch to Mercedes engines. I'm not saying it's going to happen.
And this is where this is where I wanted you to take this. This is fantastic.
I'm not going to say it's definitely going to happen, but I've personally been reading the regulations today, in fact, and have actually gotten some feedback from Scarbs. The sticking point is, will the FIA consent to you doing this? If you can get the consent of the FIA, seemingly you can do it if you have the capacity to build the engines. So don't dismiss the concept out of hand that Alfa Romeo Ferrari could become Sauber Mercedes.
That's absolutely fascinating, isn't it?
Yep.
Interesting.
Okay.
I think you make a great point there. And I think so much of our time the last 3 or 4 months has been speculating about drivers. But as we graduate into this new era with these new cars and these new chassis, it also opens up the possibility of new marriages from a team and a power unit supplier perspective. If I'm Alfa Romeo now and I'm going to carry over, and we know this isn't going to happen, but I'm going to carry over effectively the car we have this year into 2022, integrating a Mercedes power unit into that car is an incredibly challenging proposition from an engineering perspective. But if I'm already building a new car, it's an easier transition and it's an easier conversation to have with the team at the factory. So I think that's interesting. And as much as we talk, and it's a lot of fun to talk about drivers changing teams and who's going to end up where, for me, I'm just as excited to talk about marriages when it comes to power units and gearboxes. And, we've talked in the past as well about the fact that if I'm Red Bull and I've now fully integrated the Honda IP and I've taken on the responsibility of developing that engine and building that engine, am I going to pursue a customer team? And if I'm Alpine, if I'm Renault, is it a valuable proposition for me to be an F1 if I'm not also feeding engines into another team? And if I'm Williams, am I satisfied with the Mercedes arrangement? So there's all sorts of conversations that we can have over the course of the coming weeks and months about, are there going to be musical chairs when it comes to power units as well, which I think is a really fascinating conversation.
Well, let the chaos begin.
Absolutely.
Okay, what was the next thing I wanted to talk about? I was actually getting a little bit ahead of myself. So why don't we talk now in the time that we have remaining? Let's look ahead to the race this weekend. It's going to be the first Dutch Grand Prix at Zandvoort since 1984, which has been obviously a very, very long time. We talked about it just a week or so ago. I gave a little bit of a context. Zandvoort is just west of Amsterdam. It's right on the coast in the dunes, or the Duinen, as we say in Dutch. It was opened in 1948, just after the war, but there was plans actually to build and open a track there well before World War II. It's a fairly tight and compact circuit. If I could maybe draw a parallel with another track on the schedule, I would say maybe Hungary. It's the circuit length in its current configuration is 2.65 miles, or about 4.25 kilometers. There's 14 turns. The race lap record is a 131.977. That was set by Mike Cantillon, I think I'm saying that right, driving a Williams FW07C in a historic Formula One race last year in 2020. So, of course, we don't have anything to really, we don't have any context for the modern cars, but it's really going to be interesting to watch. And I think the one thing that we're all looking forward to is this reworked section of the track and the banked corners, which I think is going to be absolutely fantastic. And I'm really looking forward to seeing this, because this is Formula One almost going back to its roots. I mean, bank cornering is it's not a stranger if you're a fan of the Indy 500 or the NASCAR, where you see the bank corners on the super speedways and the oval tracks. But we don't really see it in Formula One in the modern era. I mean, you see it in some of the historic tracks, the Parabolica at Monza, for example. But I'm really looking forward to seeing this. I'm really looking forward to seeing the cars go around this track. What about you guys?
I was going to say definitely. I mean, first of all, let me dispel any lingering rumors that there may be some sort of Indianapolis 2005 situation going on with the banking at Zandvoort. That's not going to happen. Number one, the entry speeds are much slower, and number two, is a completely different tire construction. But just to touch briefly on the physics and aero part of that, the reason why banking is a problem for Formula One and not necessarily for IndyCar is IndyCar doesn't generate anywhere near the downforce that F1 cars have. And when you have the vertical load from the banking, that's just adding to the aerodynamic load. So the vertical load on the tires for an F1 car in a banked corner are astronomical. They're much bigger than you would see in NASCAR, IndyCar, or anything else, which is one of the reasons why it was a little bit tough. As far as the track itself goes, it's a go-kart track on steroids. It's a big, twisty, high G situation. Very little rest. Hungary is an apt comparison. Certainly not much time to rest the drivers' necks. You mentioned where it was located to the west is right by the North Sea. That proximity to the water tells me that wind may be a problem. If it's gusting, if you have a tailwind, again, your relative speed to the air mass, That's what sets your downforce. It can be a huge impact on the cars. And if you remember, Carlos Sainz spun in his qualifying lap in Hungary in the final corner, and you may be surprised to learn that his entry speed on that run was actually slower than his entry speed on the previous run that he'd gone through. The reason why he spun was because he had a 30 km/h tailwind. And that was enough to unload the downforce of the car to get him to spin. How do we know it was 30 km/h? Because of pitot tubes, which is something that I could talk about at some future episode. But we can measure the airspeed very, very accurately without knowing anything else besides pressures.
Fantastic. Do you have any predictions, expectations? What would you think we could see? How do you think the teams are going to prepare their cars from a tire perspective, from an aerodynamic perspective? What would you, I guess we're only a couple of hours away now from free practice 1, but what are you expecting to see over the course of the next couple of days?
From the pictures I've already seen, this is a high downforce track. Not as high as Hungary, but it's pretty high. From the rear wings that I've seen in the gurney flaps out of this is pretty high downforce. It's definitely extremely high tire wear. Pirelli put out their statement earlier that this is a tire stress level 5 circuit. Combination of the actual surface itself and the track configuration is extremely high tire wear. So I expect most cars to do a 2-stop, and maybe Checo from the top rope does his 1-stop overcut and just dominates everyone. We'll see how that works. But as far as predictions go, the only experience that anyone has in this track in a Formula One car is really simulator work, except for Max, who drove it was an RB8 a few times around Zandvoort. Most of the drivers have driven the track in lower formulae. The problem is an F1 car has so much downforce, it brakes so much better. You have to relearn the braking points, and there are going to be corners that are flat now that they weren't before. And they'll just have to figure it out. They'll have to figure out what they've got underneath them. A new track could always produce a new specialist. We know that Lewis Hamilton is a Canada specialist. We know that Kimi was a Spa specialist, right? A new track could make a new specialist, and we have no idea who it's going to be.
The other thing is, too, that I was just looking up the weather while you guys were talking. So for those of you that were hoping for a rainy weekend to kind of throw things into chaos like we saw last weekend.
None of us after last weekend.
Yeah, I don't think that's a thing anymore, but the weather looks good for Sunday at 1 o'clock on Sunday afternoon. The weather is going to be sunny. We're looking at about 68 degrees Fahrenheit or 20 degrees Celsius, and the wind's going to be blowing out of the northeast at about 13 kilometers an hour. So, a little bit kind of windy, but not too much. But I guess, being by the water, there's always the potential to get big gusts of wind, which, is referencing Carlos Sainz could certainly be making things interesting. But I don't know. I think that just based on the adrenaline, I think you have to give the advantage to Max. But I think that's going to be canceled out just to the fact that that Lewis is Lewis Hamilton. He sees the championship in his sights as well. He's going after number 8. So I think that any advantage that Max is going to get from the home crowd, I think Lewis will be motivated just by that alone, that everybody, he's going into a very biased and very pro Max Verstappen crowd. And I think that will I think that will motivate Lewis to do, for him to be at his best, just to, he'll show up and bring it on Sunday.
Yeah, I totally agree with that. And I would just like to remind everyone that Lewis is still angling for win number 100. And wouldn't it be interesting if win number 100 was at Zandvoort? Can you even imagine the chaos?
It's absolutely what Team LH is dying to see. Social media, Twitter, Instagram, Team LH is dying to see Lewis hit the century at Zandvoort in front of what could potentially be a very vocal orange crowd.
Look, I don't care where he does it. I just want him to do it.
Yeah, well, I think it would be a real statement in terms, just in psychological terms, that if Lewis could beat Max at his home track in front of his home fans, I think very much it would have been a statement the other way around if that incident hadn't happened at Silverstone and Max was able to win at Silverstone. I think that a win is a win anywhere that you get one, but I think anytime you can get a little bit of a mental edge on your opponent, I think that is always always plays well in these sort of mental games that go on between rivals. But I don't know. I'm thinking Max is going to win this one. I don't know why. This, I always tell people I'll make my predictions and then go and put your money on completely the opposite to what I said. But I think that whatever happens, unless they cancel each other out in a Hamilton-Rosberg type situation we saw at Spain a couple of years ago, that obviously these two guys are going to be on the podium. It's
and by the way, Max won that race.
He did.
He did,
His
right?
first
Yeah.
Grand Prix.
And
it was.
This is my parting word, just to prove that I'm more neutral than you guys realize. just to prove that Max is the real deal. Mention is made of how that car is tailored for him. This is a Max Verstappen team at Red Bull. The car is perfectly set up for him. Everyone else is just dealing with whatever choices he makes. Remember, when Max went to Red Bull in that race, in his first race for the team in Spain, by definition, that car was not set up for him. It was set up for someone else.
Mhm.
But he won
Daniel
anyway.
Kvyat's car.
Right. He won anyway.
Yep.
You don't do that by accident.
Yep.
Max is the
Yep.
real deal. The question is, can he go toe-to-toe with Lewis Hamilton, and can they do it without crashing? Let's find out together.
Many have tried and few have succeeded. And the one guy that did recently quit only a week after winning his championship. So, it's going up against Lewis, on the track and off the track is it's a tough thing. But I think just from what we've seen from Max, just mentally and also just from, his skill as a driver, I think if anybody can go toe to toe with Lewis Hamilton and maybe not be put off by the mental stress or the side of it, I think that that Max might have that edge compared to some of the other guys that have gone up against Lewis Hamilton. But Bryson, that was an amazing time. Really enjoyed it. It's been great fun having you on the show. Would love to do it again sometime soon. And before we sign off for the night and turn off the lights here, please just remind everybody where they can follow you on Twitter and all that good stuff.
Yeah, I am on Twitter. It turns out that's an interesting thing. I'm at Natural Paradigm on Twitter. I'm thinking of actually making another account as well to do some side things, but right now I'm at Natural Paradigm. I do try to have some variation in the things that I post, but I am a connoisseur of technology things, aerodynamic things, technical things. I will try to find some of these things and post about them when I can and share them when it's appropriate.
Awesome. Well, thanks again. It was great fun chatting with you. And if you want to follow Bryson to get some really good insight, by all means do so. If you want to see what Mark had for lunch, follow him on Twitter and all his all that good. I'm just kidding. Anyways, thank you guys for listening and watching the show. Again, as always, you can follow us on Twitter at Scuderia F1 Pod, and also if you want to get in touch via email, by all means, please do so. And you can send us an email at scuderiaf1pod@gmail.com. And that's a wrap. Enjoy the long weekend. Enjoy the race on Sunday. We'll be back on Sunday night, as always, to wrap it up. Until then, take it easy, and we'll talk to you guys again very, very soon. Bye for now.